Hello, people, and welcome back to another session. In this session, we'll be looking at effect measures. So, in our previous session, we looked at one sample and two sample tests for proportions. Effect measures are basically related to whenever we have two samples, and so this is applied to your two sample test for proportions concept. Now, basically, what measures tell us, they tell us about the difference in the proportions or the measure of differences between risks is what is known as effect measures. So if you look at the concept of proportions, basically what we are dealing with are risks or probabilities of outcome. So whenever we talk about the counts of success amongst a total population, we represent that using P1. And what is this P1? It's nothing but counts of success upon total. This is nothing but my proportion. Now, from our previous session on two sample test for proportions, let us suppose we have two populations, P1 and P2. We have taken two samples from those two populations, which is represented by P1 cap and P2 cap. So there are three different entities, or there are three different mathematical mathematical terms which we can use for effect measures. The first one being risk difference. Now, risk difference is represented by RD, and it is just equal to the difference between the two proportions. Now, depending on the resultant quantity, if this quantity is greater than 0, it means that there is higher risk in the first sample than my second sample. If this is less than 0, it means that there is more risk in the second sample as compared to the first sample. And if they are equal, basically there is uh, the risks in both the samples are equal. The next estimate or mathematical term is risk ratio, also represented by RR. It is equal to P1 cap by P2 cap, or it can also be represented by P2 cap by P1 cap, depending on which sample you want to take it as your reference group. So if your second group is considered as a reference group, then you will be doing P1 by P2. And if your first sample is considered as the reference group, you will be doing P2 by P1. Now here's the difference. So if P1 by P2, I consider this entity, and let us suppose it is greater than 0, then it means that there is higher odds of risk in P1 than in P2. Okay, there is more risk in P1 than in P2. If this entity is less than 1, then it means that there is more risk in P2 than in P1, right? So let me repeat myself. If we are taking the risk ratio P1 by P2, and if this entity is greater than 1, what it means basically is that if this entity is greater than 1, it means there is more risk associated with the first sample than the second sample. Now, changing my reference group, if I take P1 as my reference group, then the situations or the conditions are going to get reversed. If I do P2 by P1, it means that there is higher risk in P2 than there is in P1 when this particular entity is greater than 1. So basically, if P2 by P1, this is greater than 1, it indicates higher risk in P2 as compared to P1, which is opposite of this particular scenario. So based on the reference group, you will solve problems for risk ratio. And now coming to odds ratio. Odds ratio is given by V1 cap upon 1 minus V1 cap divided by P2 cap upon 1 minus P2 cap. This is nothing but my odds ratio. So if this quantity is greater than greater than 1, it means there is higher odds in the first group as compared to the second group. And if this quantity is less than 1, then there is more risk in the second group than in the first group. So odds ratio basically tells us the odds of that event happening, or the odds or the chances of that particular event occurring. So we are comparing the odds of our sample 1 with the odds of our sample 2. So these are the three estimates of effect measures. You have risk difference, you have risk ratio, and you have odds ratio. Now let us look at a problem. The problem says, suppose we are interested in the association between gender and risk of having a coronary event in a high risk patient population who have had an event in the past. We have data for 25 females and 25 males. We followed each subject for a year to see if they had another coronary event, defined here as success. So this is the table given. Your male count is 25 and your success count is 18. Your female count is 25 and your success count is 8. So accordingly, you calculate P1 cap. And P2 cap. After calculating both P1 cap and P2 cap, you are ready to go ahead and calculate your effect measure estimates. So what will be the risk difference for this? Let us calculate P1 cap by P2, P1 cap minus P2 caps, which is 18 minus 8 by 25, which is going to be 10 by 25. 0.4, which indicates there is 40% higher chance in sample 1 than in sample 2, or 40% of that event happening more for population 1 than for population 2. Risk ratio, considering P2 as my reference group, this will come out to be 18 by 8. This is going to be 9 by 4. This is going to be 2.25. So higher risk in 2 point. So the risk of the event happening in population 1 is 2.25 higher than in population 2. This is what risk ratio tells me. And if I have to calculate odds ratio, I'll do it like this. 18 by 25 upon, what is 25 minus 18 is going to be 7. We have P2 as 8 by 25. Okay. 25 and 25 is cancelled. 25 and 25 is cancelled. So we have 18 into 70, divided by 7 into 8. Nothing but equal to this. Your denominator is going to be 28. This is going to be 153 by 28. Clearly, this entity is greater than 1. So again, higher odds in P1 than in P2. So this was the concept of effect measures. With that, we conclude our topic of effect measures. I'll see all of you all in the next session with a new topic. Thank you.